Hello, Algebra 2 students. Glad you found some time to do your notes. Today we're going to be looking a little deeper into factoring. Specifically, we're going to be looking at factoring trinomials when A is equal to 1. Tell you what that means here in just a second. Copy down the title as well as the objective. Our objective for this day is the student will learn the process and procedure for factoring quadratics when the A term is equal to 1. Now you're going to very quickly see that this is a completely different strategy as far as factoring is concerned. The stuff we just looked at yesterday was basically trying to find something in common between all of the terms. This is going to be a different operation altogether. So let's get started. Okay, now as you should recall from our discussions back before Christmas time, our typical trinomial, okay, is a quadratic, and the standard form of a quadratic is ax squared plus bx plus c. And of course recall that a, b, and c are simply real numbers. They can be positives, negatives, whole numbers, decimals, fractions, zero. They can be anything as long as they can be found on the real number line. Now, our goal when we are factoring a quadratic is going to be to look for two factors that will meet a couple of conditions simultaneously. The first condition is this. We will want those two factors to be able to multiply together to equal whatever the product of the A term and the C term is from our problem. And you'll get a better idea of what that means here in a few minutes, okay? But of course in our quadratic, A, B, and C are real numbers. So that number A and that number C, they will multiply together to equal some value. We will then take that value and factor it in as many ways as we can. Okay, and that'll be part of what we're looking for, searching for two factors that will multiply together to equal the product of A and C. And at the exact same time, they must be able to do this. The same two factors have to be able to add or subtract with each other to equal whatever the B term is from our quadratic. Now, as you're going to see, it's a very specific formula or a very specific process to get this done. So we're going to need to memorize a little bit of a procedure here. So let's take a look at it. Okay, let's say for example we're looking at the quadratic expression x squared plus 6x plus 8. Okay, not a very difficult quadratic, very easy. Okay, however, let's say we need to factor it. Okay, now one of our two conditions was that we are going to need two factors that will multiply together to equal the product of the A and C terms. So we better look and see what are the A and C terms. Well, of course, A is the coefficient in front of x squared, and C is the x to the 0 term, our constant. So our values in this case are 1 and 8. Now, obviously, 1 times 8 is 8. Okay, so we're going to be looking for something that will multiply together to equal 8, and at the same time we'll want to add or subtract together to equal whatever our B term is. And in this case, when you look at the equation above, the B is the coefficient of the x to the first term. So in this case, we are looking at a B term of 6. Now, in order to get this ball rolling, what you're going to do is we're going to have to say, all right, what are the different ways that 8 will factor? How will it break down? What times what? Now, obviously, there's different ways of accomplishing 8. Clearly, 8 could be 1 times 8, and 8 could be 2 times 4. Those are both valid factorizations of the value 8. Sometimes you will see you will have a whole lot of little factors that your value will break down into. This time it only breaks down 2 different ways. Now, so we can see that our two factors are either going to be the 1 and the 8, or they're going to be the 2 and the 4. Now, how do we decide which? Well, what we're wanting also is not for these guys just to multiply to equal 8, but we also want them to be able to add or subtract to equal 6. Now here's where your common sense elementary school math skills need to come into play and go, okay, where can I add or subtract with the 1 and the 8 to equal 6? Or where can I add or subtract with the 2 and the 4 to equal 6? Now, hopefully, pretty clear to see that it's going to be the 2 and the 4 that equal 6. If we go with a positive 2 and a positive 4, we do get a 6. Okay, so after you identify what your factors are going to be, here's how you structure it. You're going to draw two sets of parentheses back to back. It's going to be a little multiplication problem. And you're going to place an X at the front edge of each of the parentheses, just like I'm doing there. And the factors that you arrived at, including their signs, will take up those spots on or in the right side of the parentheses. So basically, we are finding a way to tear our trinomial down into a binomial times another binomial. Okay, so what we have discovered is that the original problem, I believe it was x squared plus 6x plus 8, factors into x plus 2 times x plus 4. Now, as we said yesterday or last time, okay, factoring is a version of division. So if you would like to undo the division and see if you got your problem correct or not, you can always re-multiply, doing the distributive property, multiply the x times x plus 2 times x plus 4. That should get you your original trinomial back. If it does not, then something has gone wrong somewhere. Okay, well, let's look at another. This time we are looking at x squared minus 5 plus 6. Now the only real thing that changes here is this time we have a negative number floating around in the problem, and that certainly is going to happen from time to time. Okay, but the same process remains. The first thing we are looking for is the product of the a and the c terms. So what are your a terms and your c terms this time? Remember, a is the coefficient in front of x squared. That's a 1. And c is the x to the 0 term, the constant. That is 6. Okay, so we've got a 1 times a 6. Obviously, that is 6. Okay, now we're also going to want whichever values we pick to represent this 6, we're going to want them to be able to add or subtract to equal the b term. Okay, the b term this time is a negative 5. Okay, so now let's go in search of those factors. We're going to take 6 and we are going to break it down in as many different ways as we can think of. 6 equals what times what? Okay, well, obviously 6 breaks down a couple of different ways. 1 times 6 and 2 times 3. Okay. So once again, we are searching for how can we add or subtract the 1 and the 6 or the 2 and the 3 in order to equal a negative 5. Well, there's a couple of different ways to go about this one. Okay, because if you take a look at it, this one appears at first glance like both of them can possibly give you a negative 5. For example, we could go with 1 and negative 6. 1 minus 6, positive 1 and a negative 6, that is negative 5. But also on the 6, negative 2 and negative 3, that is also a negative 5. However, both of these are not going to be correct answers. Only one of them is correct. Okay, and the answer to which one is correct is going to come from this one. Only one of these guys can multiply together to get you the positive 6 that the problem had. If you multiply on the left, positive 1 times negative 6, that's negative 6. That's not what the problem had. On the right side, negative 2 times negative 3, that one is going to be a positive 6. That's what the problem had to begin with. So those are going to be the correct selection. So once again, we are going to construct our answer. Okay, we put a couple of binomials being multiplied together. X is over on the left side of the parentheses, and these two values, these two factors that you just found, including their signs, are going to take up the other side of the binomial. So our answer is x minus 2 times x minus 3. And as always, you can check it, do the distributive property, multiply these two binomials together. You should get your trinomial back. If you do not, something has gone wrong. Okay, just one more. X squared plus 3x minus 10. Okay. Hopefully you should be getting the hang of it. We need to identify what is the a times c and also what is the b. Well, have a look at the problem. What is a times c this time? That would be 1 times negative 10. That will be a negative 10. And what is the b term? The b term is a positive 3. Okay, so we're going to take a look at this 10, and we're going to ask ourselves, how will 10 factor? How will it break down? Well, obviously, 10 can be 1 times 10. It could also be 2 times 5. Okay, and keep looking. So far, the examples we've seen have only broken down 2 different ways, but they could break down a bunch of different ways, especially with some of the bigger even numbers. Okay, but for so far, all we have seen is just each of our problems. Our product is only broken down 2 different ways, but it could break down a bunch. Okay, so now we are looking for either 1 and 10 or 2 and 5 need to add or subtract to equal a positive 3. Well, I think it's pretty clear to see over on the right side, the 2 and the 5, if we have a negative 2 and a positive 5, that will be a negative 3. Okay, so that's everything you need. All you have to do is construct your answer. We've got x minus 2, and we've got x plus 5. You can get your answer. And for those of you that are concerned with getting questions right and wrong, always check it to be sure. All right, these problems are a little bit easier than some of the ones we will get into, specifically because all of the a terms, our coefficient in front of x squared, has been a positive 1. We're going to get into it soon about what happens when the a is not a 1, but for today, that's what we're looking at. So in conclusion, I have a couple of problems that I do want you to copy down and work out in your notes as part of your notes. Okay, our first trinomial that we're looking at is x squared plus 10x plus 16. Copy it down and work it out in your notes. And then I have a second example for you to work, and it is x squared minus 5x minus 24. Copy it down and work it out in your notes. That is the end of the audio for this lesson. I appreciate you finding time to tune in and do your notes. I will see you in class.